an important factor? Okay, great. That's a lot of hands, and what we are here about, what I'm here today to talk about is RemoteFX, and RemoteFX is Microsoft's answer for providing a great end-user experience for remote desktop users. So my name is Karthik Lakshminarayanan. I'm a group program manager. I work on the engineering team with RemoteFX, and I'm here today to talk about RemoteFX in a lot of detail. I really hope that you guys will get a lot of good information that you'll use to evaluate if RemoteFX makes sense for your environment. In terms of the agenda and the objectives, I'll talk about what the value proposition is. I hope you guys get a clear picture of how RemoteFX contributes to Microsoft's strategy, contributes to VDI, and providing that great end-user experience. We'll talk about the architecture. I'll walk through, the bulk of the slides will be about walking through the architecture, the different components that exist, and how they all come together to enable this user experience. So I'll do a demo in terms of the agenda. We'll talk a little bit about the value proposition, but then there'll be a lot of architecture-related slides. Please do ask me questions as we go. I'll try to make this as interactive. I know it's Wednesday evening at 5 o'clock, and the turnout could be better, but thank you all for coming again. So when we talk about the Windows experience, we do have to start with the traditional PC. And the traditional PC has a lot of advantages. For example, it's a very powerful computing device. It can run all kinds of applications, and it's also flexible, especially for offline scenarios and mobile workers. The advantages of just a traditional PC is tough to beat. Has some other advantages as well. It's, you get it in a diverse sort of form factors, if you will. But it also has some drawbacks or disadvantages. So when you think about, from an enterprise standpoint, you do require a local IT pro. So if you have a branch office type deployment and someone is having a PC and they are using that for their work, and there's a problem with it, then now you require a local IT pro to go debug or diagnose what may be going on. It's not the most green IT friendly device. It can consume at peak 170 watts of power. And if you have regulatory or compliance type requirements, then it makes it difficult as well. It's harder to implement with a traditional PC. Hardware failures is kind of tied into the local IT pro in the sense that if there's a problem, not only is the PC unavailable, but from an end user standpoint, the productivity standpoint, they could be blocked till the PC is restored or brought online or is just functioning again. So the traditional approach that we've taken is to take these desktops, move them into the data center, and then run them on a server, right? So this is what we've enabled with remote desktops in general. And now this comes with a set of advantages. You can manage this PC or desktop from anywhere. So an end user, if they have a problem, you can just give them a new desktop while you troubleshoot what may be going on. From a green IT standpoint, the power footprint is now more managed because you're running more desktops on the same server. It is easier to implement regulatory or compliance requirements. And in general, you'd say that from an IT pro standpoint, running desktops on the server in the data center is pretty darn good. So from an IT pro standpoint, I think you've enabled a lot of the advantages. One of the downsides that has happened with this is the end user experience tends to be average. It depends on what they're trying to do. If you have some homegrown, application, a line of business application, it's likely that it works just fine. But if they want to really use this as some sort of a desktop replacement, there are many applications that either work poorly or don't work at all. So what we've tried to enable with RemoteFX is try to give you the benefits of the server-based desktop or server-hosted desktops, but also give you the experience that end users expect. When we think about the Windows 7 desktop experience, I know a lot of desktops today runs on XP, but the Windows 7 adoption rate is picking up at a healthy trend. There's a healthy trend for Windows 7 desktop adoption. So when you think about just the Windows 7 experience, it's possible that you buy a Windows 7 PC maybe for Christmas or something like that, and you're using the experience. And then when you see that, you kind of expect the same experience if you're using Windows 7 at your work or in that environment. The other thing that we've noticed is, as you can see, web technologies are evolving. HTML5 is coming out in a big way, and most of the major companies have embraced that. So it's the experience of tomorrow. It doesn't matter if it's a desktop application or a web application. Is going to be more graphics rich, more graphics friendly, and the end users are going to expect that from their desktop environment. And as an example, IE9 has come out with what they call GPU acceleration. So if there is a physical GPU available, it will accelerate that content and make that look better. Firefox 4 has the same feature. Chrome has the same feature. So modern day browsers as well are coming out with leveraging a physical GPU if it's available. So one of the things we've done with RemoteFX is we've enabled technologies both on the server side and on the client to keep the benefits of the IT Pro, but at the same time, give you the benefits for the end user experience as well. One of the things to think about as, when you think about the traditional remote client, if you will, as you add more and more capabilities on that client, you want to make sure that the reason you moved from a PC to a VDI environment, or at least we're considering that, those advantages have not been offset. So it shouldn't be that, well, I had to manage the PC, and now I have to manage these endpoint devices, and this is net, there's not much of a delta. So one of the things that we've enabled is we enable a full spectrum of client devices, so you could use a rich PC to connect if that's your deployment configuration. We'll also let you use thin client PCs, and Microsoft with RDP, typically we've done very well if you have a rich PC or you have a thin client to connect. What we've enabled with RemoteFX is a new class of client devices that enable you to have a very lightweight client device. So you can have, for example, you could have your remote client could be a monitor with your network access, a keyboard, and a mouse. And so we can enable that with RemoteFX and still provide the full Windows 7 desktop experience. So that's our value prop in a nutshell. We hope that the advantages of VDI for the IT Pro are preserved, but the end user experience element that was missing can be added back with RemoteFX. So I'm going to just skip to a demo. I don't know if you guys are previously aware of RemoteFX or have stopped by the booth, but I just thought I'll walk you through what the experience looks like from a virtual machine environment. So just to give you an idea of what the setup that I have a Wise thin client. This is running what they call their Zero Engine or Thin OS. It's running an implementation of RDP that they've ported to their platform. And this version of RDP supports RemoteFX, by the way. And this is my server. It's very heavy, but it's a laptop and it's portable. It lets me do these kinds of demos here. But I have a RemoteFX VM. I'm just going to switch to that VM and let's see what the experience is like. So one of the things that I've done is I've already connected, and I have here just a simple. This is Windows Media Center. It has a bunch of what we call Direct 3D applications. And so first thing you notice is that you have the full Windows 7 Aero experience. So as an example, if I did Flip 3D, you see the live previews in your on these windows just like you would in your local PC. So I'm just going to play. I was playing Hearts when you guys came in. Let's try the chess game here, and you guys can see the graphics that this game has and how it shows up. This is all in a RemoteFX VM environment. It looks just like the local PC. Play this game just for a little bit, but I don't care if my bishop is going to get lost. But this is a nice experience, all from a remote desktop sort of an environment. So this is the look and feel. This experience is extremely interactive and just like a local PC. I'm going to pick a couple of other examples. Let's do some browser-based. So this is a Silverlight puzzle that we have, and you can do these puzzles. I'm just going to pick something. Pick 24 things. So extremely interactive, just like it would on a local PC. And I'm just going to use this auto win feature so you'll just see how fast things are and how responsive it is in your RemoteFX VM. So it'll auto-complete this for me, but really fast and just like a local PC. One of the things with RemoteFX is that we do require a LAN-based connection. So just out of the box, we support we just support a LAN type connection, which primarily we are more latency sensitive compared to bandwidth sensitive. So if you have a high latency network and you have like a branch office deployment where let's say you have 100, 150 millisecond latency round trip, then RemoteFX out of the box won't give you that great experience. You'll have to use a partner that accelerates RDP for WAN. But other than that, if you do have a LAN network, low latency, even up to 20, 25 milliseconds should work fine. And then you'll see this PC-like experience. Here's another example that I have. This is with IE9 that uses GPU rendering. And I'm just going to zoom in. And this thing happened a little too fast. But it zooms in, zooms out. It's extremely interactive again. So this is just another example of what we have here. Yeah, I mean, we could. Well, this doesn't have task manager. The thing that we asked for is a 10 megabit per second connection. Now, to be transparent, though, a 10 megabit per second connection works better if you have more of a quarter to half screen. Some of these that are run full screen, it will vary. I'll talk more about the technology in terms of how we reduce or compress the bandwidth consumption. But it can go up to 20, 25 megabits per, you can go that high. It just depends on what kind of application you're running, how much we're able to compress, and that sort of a thing. But if you for typical use cases, when we do these demos, we run these as full screen and so on because that's the min bar. People want to see demos that run at full screen. But from just a day-to-day interactive, just if you want to use it as a desktop, we think that a 10 megabit per second connection on a LAN is adequate to deliver that experience. So, just one other thing I want to show you because this will feed into the architecture. One of the things that we have done is we've done GPU virtualization. So there is actually a graphics adapter in the server in the host partition, and we are able to virtualize and share that, and so that it shows up in all these virtual machines. So I just have Device Manager up. This is in the VM, and under Device Adapters, you'll see that we have this thing called a RemoteFX graphics device. So it's really our virtual GPU and our WDDM driver that runs inside the VM. And I'll touch on this as I walk through the various components. But this is what happens for these direct 3D applications, rich graphics, rich multimedia applications, is that they believe that they actually have access to a physical GPU. So when they make, for example, DirectX API calls, it looks like the graphics adapter is present. They have no awareness, and our technology has no awareness of whether the graphics adapter on the server is NVIDIA or ATI. So it's pure virtualization in that regard, just like you'd expect, say, from a CPU, for example. You don't know if it's Intel or AMD, and it's the same way here. So, yeah, go ahead, please. Right. So what happens is it's an inbox driver that's available in Windows 7 Service Pack 1. And when you install this device, so what happens is as you build this VM, and if you use Hyper-V Manager and you're familiar with that, today without Service Pack 1, you can configure that this has 2 virtual processors or how much memory you want to allocate. What will happen when you upgrade your servers to Service Pack 1 is you'll now see another device, which is the RemoteFX graphics adapter. So you can now configure a virtual machine to have this graphics adapter. And so when you configure your virtual machine to have this graphics adapter, just like how PNP plug and play works, this is an inbox driver, and it'll just kick in, install itself. There's no drivers that you have to find. And as long as you have Windows Update, if there are any bugs or anything like that, you'll get the hot fixes or bug fixes that way. So it's an inbox driver, and it looks like it's our graphics card. So it's not an AMD card or an NVIDIA card. It's a RemoteFX graphics adapter in the VM. Other questions? Yes, please.
What kind of video card needs to be in the host?
Yeah, so the question is what kind of video card needs to be in the host? And so we support both AMD and NVIDIA cards, and we have a RemoteFX logo program. So it's part of the Windows logo program. So we have some certified cards that are certified for RemoteFX. So there are various models from NVIDIA and AMD or ATI that you can use. So as an example, one of the requirements that we have is that we require a minimum of 1 GB of video memory on the card, because it's not like we need 1 GB for one VM, but we want to really make sure that the card that you put in is used by multiple VMs. And I have a table later in the slide which talks about roughly how much is the video memory consumption on a per VM basis, or just the bottom line, how many VMs can I get from a single card? Yes, please.
Your laptop doesn't have 1 gig of video RAM in it, does it?
My laptop, I don't know how much. I'm using the Vice client, but that one at least should have 512 megs, right? And what I've done here, frankly, what we've done here is this takes about 125 megs of video memory. That's how we've allocated for this display resolution. It's a little bit more involved. We do look at what kind of screen that you have, what's your display resolution. So if you have a 1920 by 1200, for example, and you have multi-mon, and we support that, it's going to use a lot more video memory because we have to allocate for you running 2 full screen applications in both these monitors, right? So it does take more, but for this kind of a display resolution, we take 125 megs, which tends to be a lot lower than your typical PC. Other questions? Okay, so I'm just going to switch out of the demo, and I'm going to get back to my slides here. So this was the key element here. So from a guest standpoint, it just looks like I have a RemoteFX card on the server and in this VM, and otherwise it's just otherwise it's just Windows behaving normally. The apps don't know that they are virtualized or not. There are no shims that are expected for the app to work. So that was a demo, and so I'm now going to walk you through just the various pieces and how it comes together. But before that, I just want to introduce you to a new concept that we've added. The version of RDP that we released in Service Pack 1 of Windows, we call that 7.1. 7.0 was what was shipping in the RTM version of Windows. And primarily, we've added support for the RemoteFX codec. That's how we are able to take this content and preserve the user experience or the fidelity, but at the same time reduce the bandwidth over the wire. But we've also changed the paradigm in terms of how RDP has traditionally operated and how it operates for RemoteFX. So 2 concepts, many of you may be familiar, but just as a refresher: client rendering, where we send, the content is intercepted. There's awareness of what graphics content this is, and then you send the content pretty much in the native form over to the remote device, and then the remote device actually renders and processes the content. So it's as if I was running the application locally. And on the host rendering side, which is what we've started to do with RemoteFX, everything runs on the host, and then you just send the rendered screen, which is really bitmaps of what that screen looks like. We compress that using the codec and send it. So this is a shift from how RDP traditionally operates, because it will try to intercept based on the content type and then send it over to the remote client and let the client process it. So I want to do some pros and cons, or just a comparison of how these technologies work with each other. So on client rendering, you do require a separate host intercept for each content type, because you need to be aware that this is Flash or Silverlight or GDI, for example. With the host rendering concept, we have a single intercept point. We are agnostic of what the content type is. We're able to intercept that and give you a predictable UX. One of the things that happens with client rendering is that if there's a new format that comes out tomorrow, today Flash is popular. This is my example. YouTube, for example, is owned by Google. Google decides I don't like Flash. I want to come out with G-Flash, and they make their own format. Now, if you have a client rendering model, you got to update your client to build that intercept point for G-Flash. Whereas with host rendering, it's going to continue to work, because as long as it works in a Windows client PC, it's going to work here. The next point about client rendering is it does do a much better job of leveraging rich client hardware and software. But it does require a client that is capable of, for example, has the right codecs for Flash or H.264, that sort of a thing. With the host rendering concept, all the complexity is on the server, and this is how we are really able to extend the spectrum of client devices and access lightweight clients, or enable really these low complexity clients. One thing I do want to do real quick, I want to just pass out these 2 clients. These are from our partners. If you guys don't mind just passing this around. These are 2 clients that we have that are built with our dedicated hardware, and they're low complexity clients. They're not your traditional clients in that regard, and they're a lot cheaper as well. I'll touch on it a little bit later. I wanted to make sure you guys can at least touch and feel that. The last point is that when you do have client rendering, the advantage of client rendering is that it does lead to better bandwidth utilization because you're now sending the content in more of a native format, and so it's going to reduce the bandwidth consumption that way. When you're using host rendering, you do get a predictable UX. You can extend to lower complexity client devices, but it does require typically more bandwidth because you're sending everything as bitmaps. Compressed bitmaps, but it's still more than native content. Any questions on this? Okay. So what I have here is, when we talk about RemoteFX, it actually includes a set of components or technology pieces. I want to walk you guys through what that is. So on the left, I have the enabling technology, and how does that add value from a customer standpoint. So the very first thing is what we call vGPU or virtualized GPU. And the primary benefit for the end user is that they now get this full Windows 7 desktop experience in their virtual machine environment. There are benefits for the IT pro as well because they're now able to take a single GPU, put it in the server, and get better utilization out of it than, like as you were asking, if you have one client, it has 512 megs, there's only one user that's using that. If you have a 1 GB card, you can get up to 8 users to share that card, as an example. We do support multiple graphics adapters, by the way, and so if you have multiple graphics adapters on the server, we'll take advantage of that and virtualize all of them. You can have, these graphics cards, by the way, can be internal and require a PCIe slot, or you can have an external GPU appliance where you just, so all your GPUs are hosted externally and not on the same server. Host rendering, we've kind of touched on that, but the advantage of this is applications can run full speed, and RemoteFX will take care of what it needs to do in terms of, if you have congestion on the network, for example. But from an application standpoint, they just feel, I have a graphics card, I'm just going to continue executing like I would in a local PC scenario. The next thing that we have is what we call intelligent screen capture. So what happens is, at this point, when you think about the vGPU and you do think about host rendering, when we have applications that are running, they are, they draw on the screen and they create whatever graphics and UI that they have, and this is used, and this is eventually rendered on the host, on the GPU in the host partition. So at this point, the graphics adapter has the screen in the form of bitmaps. So we have a capture component, and what it does is it has smarts about it. It's kind of like the governor on the host side. It has some smarts about, what was the frame that was previously sent, and what's the current frame, and it does some sort of screen differencing, if you will. So think of this as a camera that's constantly taking snapshots of your screen and figuring out, what portions of the screen have changed. So just like this example, like my current slides, I'm animating a portion of my slides, the rest of the screen hasn't changed. I don't need to send everything across. I just identify the deltas, and then I will compress that using our codec. So we have a codec as well, which uses the processing power of the graphics adapter as well as the CPU to compress this content. So once the delta has been identified as to what portions of the screen have changed, we use the GPU and CPU to compress that. We also have an optional hardware-based implementation of our codec. So you could have an add-on card in your server if you want, which will compress this codec entirely using the hardware, and so you get additional offload. One of the things that happens when our codec runs on the GPU is that you do get some offload on the CPU because half of the codec is being run on the GPU. But if you use the hardware-based encoder, then you can offload the GPU as well. And the advantage that you get with using a hardware encoder is that if there are spikes in the CPU usage, that has no impact on your compression, and as a result, the end user experience and fidelity is constant. So if someone's running, doing some number crunching or what have you, and there is a spike in the CPU usage, with a hardware encoder, you're going to have a consistent experience from a frame rate perspective. Of course, because it offloads the GPU and the CPU, you can get some additional scale as well. The next thing I want to talk about is our bitmap remoting and hardware-based decode. So what I talked about in the encode takes care of what happens on the server. So you found the screen, you found the portion that has changed, and now you've compressed it. The key thing that we are enabling is we just send this across as 2D bitmaps. And because we send this as 2D bitmaps, any basic display device can now access this content, understand it, and just display it on the screen. You don't really need a lot of sophistication on the remote device, which is really the reason how we are able to enable devices that look like what I've just passed around. And the other element about our codec is that it's completely interoperable with VDI, RDSH or TS, and also Windows Multipoint Server. So Windows Multipoint Server is for educational institutions where you have a single multipoint server in a class and you have multiple terminals for the students because they can all access the content and use their desktop. So, and the other element about our codec is it's completely interoperable between hardware and software. So we have no understanding, and we don't need to have that understanding around, is there a hardware encoder on the server or a hardware-based decoder on the client, because the codec is completely interoperable. The final element is what we call USB device redirection. So with RemoteFX, we've also enabled USB devices to be redirected over RDP. And as a result, I'll talk more about all this, but just at a high level from a customer value standpoint, almost all the USB devices can now be redirected or are they used in your virtual machine environment. We don't require any real drivers for this on the client, because the way USB redirection works is that it makes it look like the device was present in the VM, and it's very, very likely your USB device has a driver for Windows 7. And we'll talk more about this. But these are the key elements of our technology and how this adds value from a customer standpoint. Go ahead, please. I'm sorry? Is BitLocker supported? No, BitLocker is not supported. So that's not something that we support on. So if you have something that you use BitLocker on the USB device, that's what you're talking about, correct? No, we don't support that one. Sorry? Well, that's why you come to this session. I'm not the sales guy, but that's tough. We don't. But there's actually a pretty. Just one second. There's a very nice blog that we have. It's in 3 parts. Please go to that blog, and we talk a lot about just in a lot more detail, because I do expect a set of questions around, does this device work and that device work? I have to be honest, my memory is not the best that I'll remember every device. Please go and access that blog, and we've done a pretty nice job of just detailing what works and how things work and so on. For the most part, all USB devices should work as long as they have a driver in Windows. We do have some things like this that will not work. Sorry, you had a question? 1 second. Right, so voice over IP headsets can work as long as you have, there are a couple of things. There's voice over IP itself. So for example, that can work if you have like Skype, for example. But like I said, RemoteFX works only on a LAN. So you do need to be careful about it. Voice over IP devices like that are very sensitive to latency. So if you're going to get into, you have a low bandwidth or a low quality network connection, and you have higher latencies on it, then that's going to impact the quality. There's nothing from a purely technical standpoint for that device to work, but device to work also means a good experience. And so if you have a higher latency, you're going to find that experience is not really acceptable. So it is latency sensitive, but as voice over IP devices officially can work. There is a specific thing that I want to highlight, which is link. And people talk about, does link work? And Microsoft has not officially come out in support for link as yet, because besides the latency aspect of how link would work with these kinds of latencies, the other problem we have is there's a compliance requirement around what is called E911, which is really about 911 and being able to, if someone makes a 911 call using link with the RemoteFX VM, the 911 folks need to be able to come down and track where you are so they can help you. And those requirements have not been completely implemented, so as a result, we cannot support a link in a RemoteFX environment. But in general, voice over IP, yes. Please. You're asking about clients that have solid state, like you want SSD drives? Is that what you're talking about? I mean, there's nothing about RDP or RemoteFX specifically that enables or prevents that from happening. So whether our thin client partners want to put SSD drives or not is really a decision that they have to make. If they're available, I don't think they are. Yeah. Right. So from a codec standpoint, when we released Service Pack 1 in February, those, our codec IP is available for our partners. It takes them a little bit of time when you take the IP and to put it in hardware, and the hardware tape-out time is a lot longer than you typically think about from a software standpoint. For example, Cloudium Systems is a small startup-based company. They have a booth here in the partner pavilion, and they've told me that they're going to have clients available in the July timeframe. So they're pretty close, but it's a matter of just there's a bit of a lag between when hardware comes online and when software is online. Yeah.
In this architecture, when I've got my client on a connected server, I disconnect this client, move to another one, and get the old client state.
Are you talking about USB device redirection or just general? In general, yeah, you can get the same state. You can, yeah. It depends on how, for example, there's whether you implement persistent desktops or pooled desktops and so on, which is really, does the IT pro consciously make a decision to say every time you connect, you'll get this brand new VM, which is really a gold image and these changes, and no state is preserved. So when you disconnect, or basically no state is preserved. So when you come back, you're going to get that same thing again. So if you change the wallpaper, for example, you're not going to see those changes. So that's the pooled VM scenario, but there's nothing that RemoteFX does to disable that. It's really more of an admin and a deployment choice of whether they want to give you a persistent desktop, in which case your state is preserved, and not just across, even if you come back to the same device, it'll be there. It doesn't matter. It's really associated with you and your VM compared to what device you connect from. There was a question in the back, I think, yeah. Absolutely. So as an admin, you have complete control. You can do as much as, you can go all the way from saying, I want USB device redirection to be completely disabled. I don't want anything to be redirected. And you have granular control. So you have all the way from that. You can do things like, I want to enable this class of devices and nothing else. And you can go to saying, I want to enable this particular device and nothing else. So you have complete control depending on how granular you want to get it. So yeah, you have that choice. So yeah, so these were the key pieces. What I'm going to do is, if you think about vGPU and host rendering, they're kind of similar. Yeah, sure, thanks. Thank you. Oh, sorry. Yeah, so when you think about the virtual GPU and host rendering, they're kind of similar, which is really talking about the graphics adapter and how the rendering happens. The next two are kind of similar, which is really our codec, and then you have the USB device redirection. So if I had to really break this down, RemoteFX is 3 pieces: GPU virtualization, our codec, and USB device redirection. So I'm going to walk you through each of these, but let's put together what the big picture looks like. So this is Hyper-V. We only support Hyper-V as a hypervisor. So Hyper-V VDI, and then RemoteFX components, just like a block diagram of how they all kind of fit together. So you have the Hyper-V parent partition, and you have a Windows 7 Service Pack 1 guest OS. So you do require Service Pack 1 in Windows to get the RemoteFX benefits. So the very first component that shows up is RDP. And one of the changes we've made for RemoteFX, this is more under the covers, is that for RemoteFX, we've moved to user mode RDP. RDP traditionally has been kernel mode, but RemoteFX and VDI, we've moved to user mode RDP. It really doesn't change anything from an end user or from a customer standpoint, because all the protocol fundamentals, like authentication, for example, they continue to be honored. Your clients if you have older clients and you connect to this, that's not a problem. You'll have, RDP will work just the same way. But so you have RDP and you have USB device redirection that's part of RDP. I'm going to touch on USB device redirection just a little bit later, but so at this point, just think of a connection that's come in, and you have applications that are running, or you start some applications inside your VM. So the first thing that happens is within the VM, once the admin chooses for this VM to have our virtual GPU or graphics device, we have this inbox virtual GPU driver that gets installed. It has a user mode and kernel mode component, just like any WDDM driver. And this is how we really expose the host GPU inside the guest OS. So what happens here is when applications run, let's assume they make some sort of DX9 API calls. Our WDDM driver that we have inside the guest, it says, yeah, I'm a real WDDM driver, but it's really aware of the fact that it's in a VM. So when these API calls are made, it actually proxies them over to the parent partition. So it acts and behaves like a WDDM driver, but does no local rendering. And so we have integrated with Hyper-V, and specifically their VM bus, and we have a shared memory. So this is more of their transport layer. The other thing that we have with the Hyper-V platform is we have a service that runs that is managing the life cycle of these VMs and the GPU memory allocation. So for example, if you have this VM running, then some amount of GPU resources are allocated for it. If another VM starts up, resources are allocated, but if a VM is shut down or disconnected, then you want to make, this one will take the resources back, and it'll keep an assessment of, it'll keep a running count of how much GPU resources are available. So at any point in time, if you've exceeded the number of GPU resources, for example, and you try to start a VM, the VM will not start because you just don't have access to that graphics adapter anymore because it's full. It's already been allocated for the other folks. So the lifecycle management is also done with our Hyper-V integration. So on the parent partition, we have a component it's just more of a block diagram here. It's at a high level. It's called RCC. RCC stands for render, capture, and compress. So the very first element of that, which is render, what happens is these APIs that the apps were calling are now redirected over to the host partition. There is one RCC component for every VM, so the security context is maintained, and you don't have to worry about this being shared across multiple VMs. So there's one RCC component for every guest VM that's running RemoteFX. So what the render component does is that it will now actually make those actual calls. It'll use the actual GPU. This is the physical GPU, NVIDIA or ATI, and using the GPU vendor driver. And at this point, the screen, the VM screen is now present on the GPU as an off-screen surface, and it consists of 2D bitmaps. And so then our capture component comes in, and what it does is it really composites the screen. Just like you have your desktop window manager that does that for you on a local PC, this will do that for you from a VM standpoint. So if you have multiple VMs, for example, multiple monitors, for example, it'll figure out which app is in which screen, kind of composite the whole thing. And then this is when it'll do what I talked about, which is the screen delta. So it'll look at what's going on and it'll find out which portions of the screen have changed and identify that for compression. And so we have a RemoteFX codec which will run, which uses the GPU for the first phase. So it has two phases. So here you have some additional offloading because the GPU is used right now for compression as well. So it's not just used for rendering, it's also used for compression. And we get some offload that way because you don't have to worry about your CPU is offloaded. There's a second phase to this codec which does run on the CPU. Now this is what we call our software implementation. It does require a graphics adapter, but it's what we call a software implementation because we have real hardware, which is our RemoteFX hardware ASIC. So you can have an encoder now in the server, which will have an ASIC driver. So at this point, once the render component finishes the rendering and the capture has done its screen deltas or has figured out what portions of the screen need to be compressed, you can now give that entire payload over to the hardware and let that compress it. So this is how you can get additional offload for GPU and CPU. Once this is compressed, again, it's completely interoperable as a format. There is no awareness of whether it was to the remote client, whether it was compressed using the GPU or our hardware. The compressed payload is sent back to RDP in the guest partition, and then it goes out just like a regular over your RDP connection. What I'm going to do next is just walk through like virtual GPU, which is the first component of our RemoteFX architecture, walk through that. Then I'll do the codec, and then I'll do the USB device redirection. Any questions so far? Yeah, please.
What is the advantage in using RemoteFX ASIC rather than perhaps just a second GPU?
Right, so the question is, what is the advantage of using the RemoteFX ASIC compared to, say, just adding a second graphics adapter? And so specifically to think about, the ASIC is specifically for compression, whereas the graphics adapter is for rendering as well as for compression. And if anything, I would say the graphics adapter is a lot more for rendering. It does a little bit of the compression because there's some efficacy because you've just rendered the screen. It's already in the graphics video memory. You don't have to do any additional copies and stuff like that. So that helps in that way. But if you really think about the applications that are running, and if you really run intensive applications that require a lot of graphics power. Most of that compute resources are really for the rendering more than the compression. And so the ASIC is not going to help with that. It's more of a codec-only feature. Okay, so I have the virtual GPU. I'm going to break this down into more detail. And so to set it up, I have the Hyper-V parent partition, and then I have the guest partition again as a child. So I have the plumbing pieces here. I have the, I talked about the VM bus, and I talked about the Hyper-V transport layer. So there's integration on the host side, which is what we see on the left, and that talks to RCC. And then you have, similarly, a component in the guest, which is our virtual GPU driver, which integrates with this transport, and it does the child integration that way. So what we have is, I just picked a couple of examples, IE9 or a Windows application. These applications will continue to run as they normally do, and they'll make API calls like they do today. And our RemoteFX vGPU driver, because it's a user mode and kernel mode WDDM driver, will take these APIs and convert them into what we call DDIs, or device driver interfaces, and then it'll send them over to the parent partition. So there's some amount of translation that's happening here because it has to act like a driver as well, but it sends them over to the parent partition, again, using this transport layer that we have, which is VM bus. And so the RCC component, once it gets that, it'll convert that back to APIs, or it'll convert that back to DX9 APIs. One thing to remember here is we support DX9. There are newer versions of DX out there, like DirectX 10 and 11, but what we've noticed is that a lot of the applications really use DX9 because that's what was available with XP, and XP being so predominant, people didn't really move to DX10 or 11. The other element to think about is, most applications, even if they're DX10 applications, do have a fallback mode to DX9. So you can use DX9. They check if you're DX10. If not, they move to DX9. So far in all our testing, we haven't seen that being a problem of using DX9. It uses DX9 APIs, and this is where there's the GPU vendor driver, and we just render on the GPU. One thing to remember here is we have no awareness really that this is an AMD driver or rather ATI driver or NVIDIA driver. For us, it's agnostic, and we treat it the same way. So at this point, the app made a call or a set of calls, and those calls were sent over to the host partition. It's really, if you think about it, if you had a local case, you would have this vGPU driver directly writing to the GPU. We've just added this plumbing so that it converts this from an app to a driver call, back to a driver call to an API call, and then actually write to the GPU in the host partition. Any questions on this? Yes, please.
So is the host or is the GPU able to offload and process most of the rendering, or are you seeing it still on the system?
I'm sorry, can you say that again? Is it offload to?
So on the rendering piece, right?
Yeah.
Are you handling most of the rendering, or is the actual host CPU memory still taking it?
No, I mean, all the rendering is done by the GPU. We do not use the CPU for rendering. We use it for, we do use it for compression, like we talked about, but all the rendering is done in the GPU. Yeah. Yes?
Since you're sending image tiles, doing like CUDA processing, this won't help at all.
So for CUDA processing, this won't help at all. And you're right about that. We don't support CUDA because mainly the key issue for us here is we use DX9. We really use DirectX as a platform. What you're looking for is for CUDA to be a platform, then we need to have an understanding of this is CUDA, and then build a similar, really, if you think about it, another layer for CUDA, and just to extend that, another layer for OpenGL, right? So we'd need to have a similar flow that understands all the OpenGL calls, or understands all the CUDA calls, and then use it that way. So it will not work, you're right. Other questions? Yeah.
The RCC I thought that was the piece that fed the codec, the RFX codec, and not anything was there.
So this is just the R in the RCC, which does the render, and then the capture and the codec is in the next part, which is, you're right, that's the codec. So all this does is, okay, it's receiving, think of it as a listener, it's receiving information from the guest, and then making API calls, so that at this point what you have is the VM's desktop is rendered and is available on the GPU as 2D bitmaps. Okay, so I'm going to move to the next component, which is our codec. So similarly, like the last time, I'm just going to set up the plumbing here. a virtual GPU driver, you have RCC. And so one thing to remember here is for our compression. So now what happens is we have these 2D bitmaps. They are present on the graphics adapter. And so for compression, we use DirectX 10 API. So as I mentioned, the first phase of the codec does run on the graphics card. And we use DirectX 10 APIs because most of these cards today are DirectX 10. And DirectX 10 gives us some additional advantages. So we use some shader language programming, some more GPU programming, really. And so we use some advanced APIs that are available in DX10 because we get much better performance that way. And again, because we use DirectX 10 APIs, we are completely agnostic if this is an ATI card or an NVIDIA card. Now, if you recall, so this is our capture and compress. So what happens is once the rendered screen or the 2D bitmaps are present on the graphics adapter, our capture, again, like before, will run through and figure out what portions of the screen have changed. Now, our capture component is also smart about figuring out not just what's happening on the host, but what's happening on the client, in the sense, if you have a client that's slow and hasn't been picking up all the frames that you're rendering. So let's assume you have a slow client, you render really fast on the server, so you're generating a lot of frames on the server, but from a client standpoint, maybe the connection is slow or what have you, it's not really taking or asking for every update. So what our capture component does is it will selectively drop frames. The end user experience is that you get a smoother experience as opposed to, you guys may have seen some videos or you might have experienced this yourself with RDP, where RDP will send every packet across, right? Once you make an assessment at connection time, so you go to your MSTSC client, for example, and you can self-select whether you're on a LAN or a WAN or satellite or dial-up or what have you. But once you've made that assessment, RDP will do some optimizations, but it'll send every packet every time. So our capture component is more dynamic, where it'll figure out, looks like you're behind, I could drop some frames. And same as with our frame differencing, it'll look at what frame was last sent to you and try to figure out what it needs to compare against. So it's not always the previous frame, so it has smarts built in that way. The other thing that it does happen if you're interested is that the capture component is also good at giving you more updates if you want. So if you really do have a fast network and you want to have that pristine experience, again, this is all controlled by the admin in terms of what kind of user experience you want your users to have. But if you do choose and say, just give me the best possible experience, I have a lot of bandwidth, go ahead and use it, capture can push updates just as fast as the client can consume it. So on both sides, we'll adjust, although we all admit the likely scenario that you can just consume and we'll send you more updates is less likely. What's more likely is you have a bandwidth-constrained network, and you really need capture to sample and send you fewer frames so you get a better user experience. So as far as the compression is concerned, again, we have two phases. The first, sorry, go ahead. What sort of frame rates? So you can, for example, there is a GP setting or a group policy setting that lets you pick between all the way from, what we call the least, which is the best user experience, and then there's like a medium or an average where it's a balanced, and then you have the one which says, optimize for network, and I don't care as much about the user experience. So I don't know if you had a chance to look at, there was a talk yesterday where we walked through all these frame rates and the impact that it has on CPU and so on. But we've seen, at the high setting where you want to have the best user experience, we've gone up to 37. And if you go down to what the least was, we can go up to 22. Again, it all depends on the kind of network. If you really have a constrained network and you say, I am on a LAN, you can always fool out. RDP has no auto detection, right? You can say, I'm on a LAN, and you might be on a really poor connection, if you will. And so in that context, we'll try our best to sample and so on. But assuming you have a reasonable connection, like I said, at least 10 megabits dedicated on a per user basis, we've seen frame rates between 22 to 37 for the workload and scenarios that we went through. So we had some Word and multimedia and PowerPoint and that sort of a thing. So we had a few different applications in our mix, and this is more of an average across that period. Yeah? It's what we call visually lossless. So what happens is that we have detected, the way our codec works is that we look for areas of the screen that the eye doesn't pick up. So we look for some frequency content that the eye doesn't pick up, and we don't send that information. So from an end user experience standpoint, it looks like it's pretty good. So that's why we call it visually lossless. But it is not, pixel for pixel, everything that's rendered on the host is not transmitted to to the client device. Our target scenario really, when we think about it, is for everyday users who want to, and for businesses that want to move to Windows 7, and for various reasons want to move to VDI, so want to have a Windows 7 deployment on VDI. For these folks, that user experience is great. If you're thinking about medical imaging and stuff like that, where, I don't want my doctor looking at my x-rays that have some pixel loss in them, right? So that's not a scenario that we are really targeting here, because a lot of them also tend to be OpenGL, for example. Other questions? Okay, so this is our codec. Again, we have an optional implementation where if we detect that there is the ASIC, and then we'll just offload the entire compression. We'll save both the GPU and CPU cycles by using our hardware driver. So once this is compressed, the compressed payload again uses this transport layer, and we send it back to user mode RDP, or which is RDP running in the guest VM, and then it goes out over RDP just like it does today. Any questions on this? Okay, so we touched what the codec looks like for VDI. So let's take a look at what the codec looks like for RDSH. So on the next slide, I actually have a comparison of, when we talk about RemoteFX, what's available for VDI, what's available for TS. But let's look at, the codec is available for TS, so let's look at, how it works in a TS scenario. At a high level, most of these components have not really changed. We still use kernel mode RDP because we're talking about terminal server here. And, we have TS core, which is running, you have your LSM, which is your session manager, term serve, RDP WSX, which is our user extensions for server. And then you have applications running in these user sessions. And they continue to, then you have GDI, which has a kernel mode and a user mode. And at this point, everything is similar. There's no RemoteFX specific attribute here. We have our display driver, which is a 2D display driver. And what happens is, if you have content that is going to be compressed on the server, so for example, if you have Flash, for example, RDP doesn't redirect that. It's rendered on the CPU in terminal server, and it's compressed using, today without RemoteFX, it's compressed using one of the other codecs. But if you have RemoteFX and it's available with Service Pack 1, then our codec will run. We've actually made an implementation of our codec run entirely on the CPU. So the exact same codec, it's interoperable from a wire format standpoint, but here we do not need a graphics card. It can run entirely in the CPU. And again, our hardware ASIC comes into play here as well. It can work for both TS and VDI scenarios. So once we detect that this content needs to be compressed on the host, there is an option now. This is actually a group policy that's off by default, but as an admin, you can go and turn it on and say that I want the RemoteFX codec for my scenario. And in that case, the implementation that works on CPU will kick in. And then once that's compressed, it goes out just like it would today without, if you just had, this is just regular RDP for TS. It's just the extra piece we have is the implementation of the RemoteFX codec using the CPU. Any questions on this? So I have a comparison chart here of what RemoteFX looks like for RDVH and RDSH. We've seen a lot of questions where people will say, for example, I'm going to use a GPU in my server for terminal server. Can I get GPU sharing in terminal server with RemoteFX? So here are some of the hardware software requirements and from a feature benefit standpoint. So let's just walk through these. The first thing is what we call CPU with SLAT, which is really, it stands for second level address translation, but really every server that you have right now, anything that's shipped in the last 2 years has SLAT on it. This is Intel, EPT, AMD, NPT. This is their marketing terms, or these are their terms that they use. So that's not a big deal, but you do require that for if you have some really old servers and you're trying to run RemoteFX for RDVH or VDI, it won't work. But then you have CPU with what is called SSE2, which is, I think, streaming SIMD extensions to, which is really what we try to do is for our codec to work, we need a set of instruction sets to be available on the CPU. And SSE2 is even older than SLAT, so if you have 3-4-year-old servers for TS and you're going to upgrade them to Service Pack 1, it should just work. But that is a requirement for you to run the RemoteFX codec in a TS environment. So the next one is the graphics adapter installed in the host server. If you have a graphics adapter installed in the host server, you do need that for VDI. If you install a graphics adapter for TS, we won't do anything with it. The next thing I just wanted to call out was Windows 7 SP1 virtual machine. I think another question, a variant of the question, can I get RemoteFX for TS, has been, what if I run my TS in a virtual machine that now runs with Hyper-V and has a graphics card and the host adapter? Will that work? Well, the key thing is that we only support Windows 7 SP1 guest, or the client operating system, in the virtual machine. So if you run a server operating system like TS, you won't get the WDDM driver in there. You do require an RDP 7.1 client. So as I said, 7.0 is what shipped with RTM. 7.1 has support for the codec. So when something's compressed using RemoteFX, our client is able to understand and decode that. So in terms of features and benefits, you have GPU virtualization. One thing that people may be thinking about is, I don't know how important it is for you folks to get a GPU in the server, but one of the things about TS is that you get a lot more sessions out of it than you do with VDI. So if you're thinking about 200 sessions in TS, and you think about how many GPUs you would need, it just is physically not possible to put all these kinds of GPUs in there and get that kind of scale. The second thing that we've noticed is with TS, most people tend to run task worker type workloads. They occasionally are looking for some multimedia content, but not all the time. And so for that, we feel that the codec is adequate. USB redirection is available only for VDI. Again, full disclosure, I know that we would love to have made this available with TS. It was primarily an engineering and scoping decision because, as I mentioned previously, we had user mode RDP. We made that shift. We made a big move to go to user mode RDP for RemoteFX. And the same work, when we did the initial planning, we wanted to make this available. We just could not make it fit from a schedule standpoint, and we couldn't make this happen. So USB redirection available only with VDI, not with TS. The whole Aero experience you can get based on any kind of client device, and you get that with VDI. And then the next two pieces are really a statement on the codec, which is really about the codec is completely compatible. It's the exact features available, so you can have CPU implementation or other software implementation or a hardware implementation, and they just work for both scenarios. Questions? Yeah. RemoteFX, the codec will work even if you virtualized it on Hyper-V. That's not a problem. No, based on the testing we've done, that I've done, I mean, that we think that should work. But it's, yeah, I don't see why that should not. I mean, if it's the SSE2 instruction set not being available, I think it should work. And we've done some testing as well, so it should be okay. And then, we can sync up offline. I'll give you my card, and I'm happy to follow up with you and to see if there are any bugs or anything like that in that regard. So one question I just want to highlight is that, a lot of times when people talk about RDP and talk about RemoteFX, people erroneously assume that RemoteFX is a separate protocol. So they say, oh, Microsoft has now this new remoting protocol called RemoteFX. I just want to highlight that RemoteFX is not a separate protocol. We use RDP, we make RDP better, and we work with RDP. So, if you think about your client to server connection, whether it's TS or VDI, RDP is still the overall protocol. The way we operate inside RDP is, this is a typical RDP, some of the various components of the protocol structure. And so RDP as a concept of graphics virtual channel. So the whole RemoteFX encoded payload goes out as a graphics virtual channel. So just think of it as a pipe within the bigger pipe, which carries the RemoteFX encoded payload. So it's very much RDP. It does make RDP better. You have, other protocols like, say, PC over IP from TerraDC and VMware, and so they have this rich experience. They do some host rendering, and they look at Microsoft RemoteFX, and there's a tendency to call RemoteFX a protocol. It is not. It's RDP is the protocol. Questions on this? Okay. So I just want to complete out. We were talking about the codec. We finished the vGPU. This is the last piece, which is what happens on the client. So when you send this encoded payload, the payload that's compressed with the RemoteFX codec, what happens on the client? So again, it's a classic RDP connection that comes in. The very first layer that comes up is the core services. This is standard RDP. And then after that, we have the RDP7 graphics provider is, if you recall, we have this RDP 7.1 client will have functionality to make it work with other, like for TS scenarios as well. So if you recall, for example, if you have Windows Media, we can do some redirection. This is a feature that's available in RDP 7. So if that's the case, we'll make a detection of, is this redirected content. But if not, if that's the case, we'll use the GPU. But if not, we have this decode abstraction layer again, where we can figure out what do we need to do. Do we need to decode using our GPU, which is our software decoder? Or whether if it's a device like that, we'll figure out that this needs to be decoded using our hardware. And what happens here is we do the reverse of what happened on the server side. So we do some discrete wavelet transform on the server to convert the content and compress it. We do the reverse here. We do an inverse discrete wavelet transform, and we convert it back so that to 2D bitmaps, and we are able to decode that again. Just like on the server, you can use the GPU and CPU in case of rich PCs, or if you have more of a hardware-based client, we'll decode entirely using the ASIC, and then the 2D bitmap is displayed on the screen. Yes? I mean, that display device is kind of like a 2D graphics device that you can have. So, I mean, from a GPU standpoint, it can directly go to the, you can think about, you're right, that there's some amount of graphics memory in the decoder itself. Okay, so I want to talk about the third piece, which was our USB device redirection, and talk about how that works. So for rich and thin clients, again, no client drivers necessary. So we have an implementation of RDP 7.1 that's available for Windows CE, for example. So when you plug in a USB device, you don't need a driver for CE. So that's one of the key elements of what we've enabled with USB device redirection. And there was a question earlier, the admins have complete control about what can and cannot be redirected. It's very granular. It's compatible in the sense it works with just about any USB device. We've at least highlighted one that doesn't work, but there are a small subset like that may not work. But overall, there's nothing in our technology that makes it hard. The BitLocker makes it a little, that's a nuance that we have to deal with. But the key thing for applications are that they don't need to be shamed, or it's transparent to them. It just looks like they have access to these redirected devices, and they use that. And if you have Windows Update enabled, then you can get the benefit of these drivers being pulled down, and for you having a relatively seamless experience that way. So I want to break this down into 3 slides. What I've done is, on the first slide, I just talk about, this is without RemoteFX, just a quick refresher, set a baseline of how how USB works when you plug in, say, a jump drive into just your regular PC. So you have user mode and kernel mode. Think of this bulb as a USB device that's not yet been fully detected, but it's been plugged into the USB hub. At that point, there's a notification in Windows, using PNP and IO Manager, which looks up, for example, what's the device ID, stuff like that. And then using Windows Update, or if the driver is present locally, we'll find the USB device driver, right? So it installs the USB device driver, at which point this device gets lit up. It's detected, and now applications can start using it just using regular Windows APIs, right? So this is how it works in a regular scenario. Now let me compare and contrast how we've shamed this and how we've made it work really for remote sessions, or for RDP. So this is what I've done, is how it works with RemoteFX. I've split this into 2 slides. On the first slide is really how it works on the client. This is the end device from which you're connecting. And then on the next slide, I'll show you what happens inside the VM. So one of the things to remember with USB redirection with RemoteFX is that we don't do any dynamic detection. So for example, when you start MSTSC, we require you to have that device already plugged in and be detected. So you can't have a session that's running and then you suddenly plug in a device and expect for that to show up in that session. You'll have to disconnect and then connect again. So for example, so this is a device that, so for example, if you're using a jump drive, you have to make sure that jump drive was available. When you launch MSTSC, there's actually a bit of a UI which shows up and says, which devices do you want to redirect? And so you get a choice to say, from an end user standpoint, you get a choice. Of course, an admin can override all that. But you get a choice to say, which devices do I want to redirect? So that's why I have this bulb that's already lit up in the sense it's already available. And so you plug it into the USB hub, and what happens with the RDP client is that it detects that you chose this device to be redirected in your RemoteFX VM. So once we do that, we actually have a filter driver, a RemoteFX USB hub filter driver. And what this filter driver does is if you have a rich PC, you likely already have a USB device driver for it. And so it will actually swap out that USB driver and put its own RemoteFX generic USB driver that's more aware that this is being redirected. And then once this is done, RDP will initiate the connection with the VM server. This is the first type. So what really has happened in a nutshell is we swapped out the driver. Now, if you have a thin client that didn't even have this driver, that's actually better because there's no driver to swap out. We just install our USB driver on top. That's it. But you take this device ID and information about the client.
What happens if you swap the device during the session?
What happens if you swap, as in you? This is all under the covers, though, so it's not like you are getting a choice that way. It happens under the covers. So if you disconnect the session, for example, it'll be swapped back. So in the sense that your USB device is available for you to use locally. So
if you start a session with the USB device, you use it.
So you can use. So one thing you cannot do is, for example, I start from one device, I plug it in over here, I connect to my VM, I just walk over to the next terminal or thin client, and I connect from here to that same VM, and you cannot expect that USB device redirection is going to now work.
If you change the USB device for another one of the same type, will it continue to work?
There's no dynamic stuff that happens. So what you'll have to do is you'll have to disconnect, and then when you change, and then you reconnect, and then it'll work. So there's no dynamic stuff there. So at this point, what we've done is it looks like I plugged the device in, and I installed my USB driver instead of the actual driver. So think of it as a really long cable, if you will, for your USB device. And so what happens is on the VM server, when the connection comes in, here we do the reverse. It looks like we ask our USB hub as if a device has been plugged in, and this will generate a PNP notification. So look, at this point, if I compare it with the local scenario, it looks like the device was just plugged in, right? So after 7 steps, we've ensured that the device is plugged in. And so when the notification happens, we have a proxy device, because this is a device that needs to sit or monitor what's going on with the actual device driver. So when the PNP notification is generated, you also get the USB device, the actual USB device driver to be installed inside the guest. And at that point, you have your application which says, oh, it looks like my device driver installation was complete. A device is available for me to use locally, and it can continue to work. And after this point, information is transferred back and forth using just standard USB request blocks or URBs.
Is that compressed in any way?
No, I don't think that's compressed. Yeah. Any questions on that?
It's not a question. Is there any COM port mapping?
I'm sorry?
COM port mapping?
So that's orthogonal. So for example, RDP has always done drive redirection, input port redirection, those kinds of things. That's always been there, and that continues to work. What we've added on is just USB device redirection. Okay, so I'm almost done, but just a couple of things. So from a technology standpoint, we touched on virtual GPU, we touched on the codec, and we've touched on the final piece, which was USB device redirection. I just want to touch on a couple of things that are not directly related to architecture, but we do want to highlight, these ultra lightweight thin clients. I pass these client devices around. This is an example of, that's my wallet and how big that device is. It's really small. Look at the kind of specs that you have on that client. When you think about green IT, that's 5 watts of power, 3 to 5 watts of power, and works very well for RemoteFX scenarios. We've had some demos in the partner booth that show how easy that is to manage. All it has is a network stack, and it has an RDP client on it. The other thing I want to touch on, which was, I think there was a question about, these cards, what kind of VMs can I get? Now, there was a talk yesterday that talked in a lot more detail about, how much memory is allocated and so on. Those slides are available for you to view. offline at any time. But I want to just give you a quick summary of what it takes in terms of RemoteFX scale. So there is definitely an element of how many monitors you have or what's the display resolution. But if you take an example of a 2 GB card from ATI, for example, which I've seen retails for roughly $1,000, you can get 16 VMs out of it. Now, one way to think about this is, oh my God, can I only get 16 VMs in a server, right? When I'm used to, if you have 2 cards, I can get 32. Is that all I can get? The way to think about this is, if you have that 50 to 70 VM number in your head, or maybe even higher. So I just highlighted HP, for example. They have a reference architecture. What they've done is they have a set of non-RemoteFX VMs, and then they also have some RemoteFX VMs. So think of this as I put 1 GPU card in, which probably has 2 GB of video memory on it, and I'm able to upgrade the experience for 16 VMs to a full Windows 7 desktop experience. And so I always recommend that you have this sort of a hybrid deployment model, because based on the charts that were shown yesterday, if you notice, there's a lot of CPU. We used an 8-core system, and even with RemoteFX and running 32 VMs, I think we didn't even touch 5 full cores. So there were at least 3 cores available on this VM. So if you run your typical Windows 7 VMs, which is non-RemoteFX, you'll be able to utilize the others and really get a high user density on your server. So that's my preferred way of how you should deploy RemoteFX, or how you think about it. That's actually all I had. We have a blog that I encourage you to try out. I'm happy to hand out business cards if that helps you. But one of the things that I want to be very clear about is, RemoteFX is new technology. We shipped it in Service Pack 1, and we've tried our best to make documentation and so on available. We have a very active web forum that you can participate and post or look for if you have questions. But please do post if you have questions. We monitor this. If the quality of our documentation needs to improve, we are absolutely committed to that. But that's all that I had. Thank you so much for being here. I believe that there is something here to scan. Yeah, I guess there is. Scan this tag, and I guess you can get a prize or something. But thanks a lot. Yeah, go ahead. Sorry. Yeah. You're right. That's one of the question is, do I need to have a graphics card to get USB device redirection? The way we do this is, like I mentioned previously, we wanted to have this for TS, but from an engineering standpoint, we were not able to make it fit. So which means that it only works for RemoteFX environments, and for RemoteFX environment means I need to have a GPU. That's how we check whether you're in a RemoteFX session or not. So that's really how to think. So yes, that's a constraint right now that it's only for RemoteFX. Yes, please.
You're stating this is a LAN environment only, and your partners are talking about accelerating this over.
Yeah.